Hi and welcome to our continuation of electrochemistry and specifically electrolysis or electrolytic cells. And in this video I'm going to look at the electrolysis of H2O. That's the electrolysis of water. So thank you for watching. Let's get started. So electrolysis, we said, is when we have a single container, and in that container we have an electrolytic solution, and this time our electrolytic solution is water itself. Now, problem with water and why it doesn't really work very well in electrolysis is because it does not conduct electricity. Water itself does not ionize very well. It does slightly, ever so slightly, but not very well. So what we need to do is ensure that there's some sort of ion some sort of ions in this water solution, so that it can conduct electricity. Something like putting salt in the solution, like stirring salt in here, or bicarbonate of soda, or there's a few things that you can actually do and introduce into this to make it conduct electricity. Let's just say we put some sort of salt in here that ionizes, and as a result it now conducts electricity. So when we do have that, it can conduct electricity. We now put in our electrodes, and we ensure that our electrodes are connected outside to a battery source or a source of electric current. Electrons then get donated here at the negative end of our battery, making this electrode receiving electrons. That makes it the cathode. Okay, I've been making this right-hand one the cathode the whole time, so if you want to choose something else, that's perfectly fine. And then what happens now is that the cathode now becomes negatively charged. Now imagine we now have our ions in here. We have H plus and O2 negative ions floating around in here, and what will happen is that the H plus ions would be attracted to these donation of electrons happening here at the cathode, which is now negatively charged, and as a result, when H gets its electron, it will produce hydrogen. Now there's two H's because it produces a diatomic molecule, so two H's will get two electrons, producing not two of these. Sorry, there's already two of them. Okay, that's what's going to happen. That's a reversible reaction. So the problem is that not unless the circuit is closed, this reaction will just revert back to donating the electrons again into the system, or back into the cathode. So we have to ensure that there's some sort of a closed circuit, so that on the one side electrons gets given into the system, but on the other side electrons gets taken out of the system. So this is going to be our anode. Our anode, that is the one from which electrons are flowing back into our battery source. And this anode, at this stage, I never said what they were made out of. Platinum is a good electrode. The reason why platinum in this case works is because platinum does not react. It's a platinum or something like graphite. Graphite is, for example, what you find in your pencils. In your pencils, that would be graphite. Let's draw the piece of graphite in here. Graphite is what you find in your pencils. That's also something that when we put it in an electrolytic solution, it doesn't react. It also conducts electricity, so it works as electrodes. Platinum, of course, that's a very expensive experiment to do, so you might want to try this experiment in some other way. But anyway, so let's get back to this. On the other side here, now we have a positively charged electrode. The positively charged electrode will remove electrons from the electrolytic solution. So we will have our oxygens here. Oxygen would be 2 negative. It would have an excess of electrons, as an ion, and then we would remove 2 of those electrons, and that would produce for me two oxygens. But now the problem is it produces oxygen, a diatomic molecule, so we need 2 oxygen ions that will lose 4 electrons, and this will produce oxygen here. So in the end, this will be the complete reaction. Okay, so we need to multiply this top one with 2, because we need to release and receive 4 electrons, so we must multiply this with 2, so this becomes 4, that becomes 4, and this one becomes 2. And so if we put these 2 together, this is our reaction. We've got 4 hydrogen ions plus 2 oxygen ions that will produce hydrogen plus oxygen. This is called the electrolysis of water. Okay, now these 2 itself is this is 2 hydrogens and oxygens 2, so we can write it like this as well. Okay, we can write it like this as well. Okay, but what will we actually see happening here? This is the exciting bit, okay, because you can actually go and do this experiment. Go and Google electrolysis of water and see how there's a guy on YouTube that puts a battery, you know, one of those square batteries in water, and then you literally see him see this reaction happening, and that's something you can do at home. Go and watch that. It's really brilliant. Okay, and so, but this is what we'll see happening. Okay, on this side, on the cathode side, where we have this reaction happening, where electrons are being received by hydrogen, little bubbles will start forming. Okay, little bubbles will start forming here in the solution. What are those bubbles? It's gas. It's hydrogen is a gas. Okay, what will happen on this side, where oxygen is receiving or donating its electrons, producing oxygen, little bubbles will start forming. Okay, now which side will have the most bubbles? Okay, well, the one producing the most oxygen. I didn't show it here, but here we've got 4. I forgot to put in my 4 on this side. Is it 4? 2 hydrogens. This would not be a 4, that would be a 2, because there's already 2 there. Sorry about that. So we would have double the amount of hydrogen than the amount of oxygen forming. So there would be much more bubbles, double the amount of bubbles on the cathode side than on the on the anode side. Spell anode correct. Okay, so let's quickly name what is the reduction and what is oxidation. Okay, so this one is getting electrons, which means it is being reduced. Oxygen is losing electrons, so it is being oxidized. Excellent, and that's it. That's the electrolysis of water, and exactly what you will see happening here. So thank you very much for watching. I hope you learned something. And there's one thing you should learn, is that electrolytic cells are not very difficult. I think from now on I'll look at 1 or 2 exam type questions, other than just these examples of very general electrolysis. So thank you for watching. We'll see you in the next video.